Hey guys, so welcome back to yet another video. In this video, we'll be trying to solve the problem split array largest sum. Okay, this is the problem of the day of Geeks for Geeks on 7 Jan. Alright, okay, given an array of n elements and a number k, split the given array into k subarrays such that the maximum subarray sum achievable out of k subarrays formed is the minimum possible. Okay, so basically, what they want us to do is that they want to they basically want us to split the main array into a certain number of subarrays such that the sum achieved by these subarrays is the minimum possible sum. Okay, so say here for example say for example you have three elements and you have k is equal to 2. It means you have to split the array into two subarrays. Now the maximum sum, or basically the minimum sum out of any combination is the one with this. If you split this array into 1, 1 and 2, the maximum sum of any of the subarrays is 2, right? So you're basically supposed to make subarrays such that the sum is minimized, in simple words. Okay. Now this is a hard question. It might be a bit difficult for some of you to understand. I'll try my best to explain. All right. So let me take out my whiteboard. Okay, so I'll just be taking an example. All right. Say for example, we have, whether we can put too dark. Okay, so basically, say for example, we have 7, then our array. Okay, say for example, we have 7, we have 4, we have 5, then let's say we have 9, and we also have 15. Okay, say for example, this is our array. Now, I'll ask you some questions and let's just see if you can find the answer. Okay. Now, what is the minimum sum in any subarray? What is the minimum sum that can be achieved in any subarray? If you think about it, the minimum sum achieved in any subarray is actually the largest element of the array. It is 15. So let's see what I mean by that. You can have as many subarrays as you want, right? Like you can have just 7, you can have 4, you can have 7, 4, 5, 7, 4, 5, 9, or 7, 4, 5, 9, 15. Okay. Now, the minimum sum achieved by any subarray is the maximum element. Now, why is that? Because, okay, say for example, I have the array 7. Okay. Of course, my other subarray will be this full thing. And the sum is one massive value, right? 15 plus 9 plus 5 plus 4. However, if I split the array to only 15 and I split all of this separately, right? For now, your least sum in any subarray is 15. Okay? Because even if you add this, it'll be some other massive value. 9 plus 5 plus 4 plus 7. If I'm not wrong, this is basically 18 plus 7. That's much more than 15, right? So in the beginning, this will be our assumption. This will change later on, but in the beginning, this will be our assumption. The least element, or like the least element sum of any subarray will be the largest element. Okay. Now I will be naming this particular element as left. Okay. So I'll be having left over here because our final aim will be to do a binary search. Okay. I'll be explaining why. So we'll basically have left equal to 15 for now. Okay. Now what is our right? Now, what if I ask you one more question? What is the maximum sum that can occur in any subarray? What is the maximum sum? It is the sum of all of the elements inside the array, right? Because for all we know, the maximum array can be the entire thing. Okay? The maximum array can be the entire thing. So basically, the maximum sum that can occur in any subarray is basically the sum of all the elements inside the array, right? So now what is the sum? If I'm not wrong, the sum should be what? 7 plus 4 plus 5 plus 9 plus 15. It is 40. Okay. So basically left is the case in which for any subarray the sum is the lowest, and right is the case where for any subarray sum is the largest. Okay. So now we can just basically like refer to this as the lower bound and the upper bound. Okay. Now we do a binary search. Okay. Because like right now we are assuming this entire thing as one single array. Okay. Say for example k is equal to uh, 3 for example. Say for example you have to split this into 3 individual subarrays. In the starting we just assume the entire array as 1. Okay. So our number of pieces, I'll refer to this as, so pieces is the amount of like subarrays we have. In the beginning the number of pieces will be 1, right? Because the entire subarray, the entire arrays are subarray. Okay. Now we need it to go to 3, right? Okay. So over here, okay. So what we do over here? Now over here, we'll do a normal binary search algorithm. Okay. We'll just do while left is less than right, and we'll find the mid value. Now what will be the mid value here? Huh? What will be the mid value here? The mid value here will basically be what? 40 plus 15 by 2. Right? That is basically 55 by 2. You just round it off, you will get like 28. Okay. You will get 28. Now, what you have to do is basically find out from the beginning up till which number we can get the sum lower than or equal to 28. Okay. So as I said in the beginning, we assume the entire array as our subarray. But now we have to shorten it, right? Like into separate individual subarrays. Now, this is the way we can do that. So if we erase this, okay. So now inside of this while we'll have a for loop. Okay, we'll have a for loop. So the for loop will just be used to find the sum. Okay, so over here we'll have a variable called sum. Let me just lower this. Okay, so sum in the beginning it will be 0. Okay, now what? We go to the first element. Sum will be 7. Second element, sum will be 11. Again, all is less than mid. Okay, we have to check if it's less than or equal to mid. Then we'll get 5. Sum is what? Sum will be 16, right? And we'll get 9. Sum is 25, right? But however, if we go to 15, 25 plus 15 will exceed our mid value. So we'll stop right here. Now we got 2 individual subarrays. We got this subarray and we have this singular subarray. Okay. Now we'll repeat the same thing for the other elements as well. So what we'll do is we'll update the value of right to mid. Okay. We'll update the value of right to mid. So mid was 28. We'll update the value of right to 28. Now what will be the value of mid? The value of mid will like change again, right? Now 28 plus 15 is 43. If you do 43 by 2, answer, if you round it will be 22, right? Now you again do the exact same thing as we did, right? So what we'll do is that in the beginning again sum will be 0, and we again take this first subarray and do the same operation on it. Okay. Now first element 7, sum will be 7. Second element 4, sum will be 11. Then it is 5, sum will be 16. Now 16 plus 9 is 24. That is more than the mid value. So we'll have one array from here up till 5. Then your 9 will be your other array. Now that is basically it. We successfully divide the array into the amount of pieces we needed, and we have to return left as the output, because like left is basically the, what should I say, the maximum sum of any of the subarrays, because you have 15 here, you have 9 here, and you have 7 plus 4 plus 5, which is big value, right? So let's see, 9 plus 7 is what? We get 16, right? Oh yeah, we get 16. So what we have to do is we have to update the value of left. Okay. Now, while doing this sequence or while doing this operation to find the different subarrays, you also have to check if the sum is exceeding left or not. If it is exceeding, we can just update this value. Right. So, for example, in this case, 7 plus 4 plus 5, it will be 16. Now 16 exceeds the value of left. So we'll change left to 16. Now we have to return left as the output because at the end they are asking us to return the maximum value of any of the one subarrays, right? The maximum value. This is 15. Then you have 9 here. Then the maximum value of the first subarray is 16. So the maximum of all of this is 16, right? So you have to output 16 as your answer. And that's basically, I know it's a bit difficult to understand, but yeah, I try to explain it to my best ability. So yeah, I guess if you rewatch the video, you get a better hang of it. But yeah, now let's try to go and code the solution out. Okay, so here, as I said, we'll just have int left equal to 0 and right equal to 0, right? In the beginning, both will be 0 by default. Now for int I equal to 0, I less than n and I plus plus. All right. Now, as I said, what will be left? Left should be our maximum element, right? So we can just do left is equal to max of left comma array of I. So like this operation will just assign the biggest value inside the array to left. Okay. Now after that, we'll do right. Okay. Right is what? Right is basically the sum of the elements of the subarray, right? So I'll just do right plus equal to array of I. So in this way, we'll find out our left and right. Right. So now we will do the binary search part. While left is less than right, what should we do? We should calculate mid, right? So int mid is equal to left plus right by 2. Okay. Now this will be an integer, of course. So now what do we do? Now if we take sum and pieces, so sum by default will be 0. Then pieces, which is the amount of time we split our subarray. In the beginning, pieces will be 1 because we'll consider our entire array as the subarray. Okay. Now for int I equal to 0, I less than n and I plus plus. What should we do here? Over here, if sum plus array of I, okay, if it is more than mid, so if it's exceeding the mid value, what should we do? What should we do? We'll do sum equal to array of I and we'll just increase pieces. All right. Now over here, otherwise we can just increase the value of sum, right? So we can go forward and still look for the point from where we have to split it. We'll do this. Now outside the while loop, or not outside the while loop, outside the for loop, we can do if pieces is more than m. Now this is an, okay, like we'll do the other condition first. If pieces is less than equal to m, which is if we didn't split it into the required pieces just yet, what should we do? As I mentioned, we have to just set right equal to mid, right? Just keep on updating the value of right. Else, what should we do? Else, it just means if we split it into more pieces than required, okay? If we end up splitting the array into more pieces than required, what we can do is that we can just set left is equal to mid plus 1. Okay. Now instead of updating right, we'll just update left and perform the exact same operations. Okay. So the amount of subarrays formed will be lower. Okay. And therefore we can finally meet the m amount of subarrays to be formed. Okay. Now that's basically it. Now we have to return left, right, outside. Okay, so that's it, I guess. But I think we messed up something here. We need 1 equal to miss 2 semicolons over here and here, right? Okay, let's compile and see now. Hopefully this runs. Okay, it runs. Let's submit. And there you go. That's how you solve this problem. If you have any doubts, do leave them in the comment section down below. And that's it for this video. And I'll see you next time. Bye.